Hello friends, in this video we are going to discuss paper 1 Jee Adv 2014 chemistry section. So let's see what the first question states. The first question states that the correct combination of names for isomeric alcohols with molecular formula C4H10O is or are. So let's draw the different isomers for C4H10O. The isomers will look like that's the first isomer. The second isomer is this is the second isomer. The third isomer will look something like this. And the fourth isomer will look something like this. Okay, so the option A states that tertiary butanol and 2-methyl propane 2-ol. Well, this is tertiary butanol. Tertiary butanol. And its other name is 2-methyl. This is the principal chain you can take, or you can take this also as the principal chain. So the IUPAC name for this compound will be 2-methyl propane 2-ol. So option A is the correct answer. Well, tertiary butanol and 1,1-dimethyl ethane 1-ol. No, since propane is the principal chain, so therefore option B is wrong. N-butanol and butane 1-ol. Yes, this is N-butanol, and the IUPAC name for this we can write as butane 1-ol. Well, there is one more carbon atom here. I must just state something like this. Okay, so this is N-butanol or butane 1-ol. So this option is also the right answer. Well, option D, isobutyl alcohol and 2-methyl propane 1-ol. Well, this is 2-methyl propane 1-ol, or we can also say that this is isobutyl alcohol. Its other name is isobutyl alcohol. This is isobutyl alcohol or 2-methyl propane 1-ol. Okay, so option D is also the right answer. So now let's move on to another question. The question states that the reactivity of compounds Z with different halogens under appropriate conditions is given below. It is monohalo substituted derivative when X2 equals I2. It is dihalo substituted derivative when X2 equals Br2. It is trihalo substituted derivative when X2 equals Cl2. Well, from here we can easily see that as the bulkiness of halogen increases, the substitution decreases. Okay, so therefore the observed pattern of electrophilic substitution can be explained by the static effect of halogen. It is explained by the static effect of halogen. As the bulkiness of halogen increases, the extent of substitution decreases. Okay, so now the trihalo substituted derivative when X2 equals Cl2, since Cl2 is the smallest out of Br2 and I2, so therefore it gets substituted at these three positions. For Br2, this position is extremely restricted because of the presence of OH and CCH3. So the static hindrance, because of static hindrance, this position is not favorable for Br2, and for I2, this position as well as this position, they both are not favorable. So the substitution occurs only at the ortho position. Okay, now the static effect of tertiary butyl group. Yes, the static effect of tertiary butyl group also plays a role here. and the electronic effect of the phenolic group. Yes, the electronic effect of the phenolic group. If the substitution occurs at these three positions, and as we know that these three positions are most suitable when phenolic group is present. So therefore the electronic effect of the phenolic group is responsible, but the electronic effect of tertiary butyl group is not responsible. Therefore option D is incorrect. Okay, so now let's move on to another question. The question says, in the reaction shown below, the major product formed is R. Well, the main thing that we need to remember for this reaction is that only amines undergo acetylation and not acid amines. Okay, so therefore this will not undergo acetylation. Only this will undergo acetylation. So therefore the reaction will look something like this. Okay, so the reaction will look something like this. So this lone pair of nitrogen will attack this electrophilic carbon. This will go up, and again this will be back, and this group, that is acetic acid, will be chopped off from this, and hence the product formed will look something like this. Plus acetic acid. Okay, so the correct option in this case is sorry, this is CH3. Okay, so the correct option in this case is option A. Okay, so now let's move on to another question. The question states that an ideal gas in thermally insulated vessel at internal pressure P1, volume V1 and absolute temperature T1 expands irreversibly against zero external pressure as shown in the diagram. The final internal pressure, volume and absolute temperature of the gas are P2, V2 and T2 respectively. So for this expansion, four options are given. Well, since this process is carried out irreversibly against zero external pressure, okay, and moreover this is thermally insulated vessel. Since the vessel is thermally insulated, so from the first line we can infer that delta T equals 0, which means that T1 equals T2. Okay, and it also means that delta U1 equals delta U2, where delta U is change in internal energy. So option B is correct. Now since this is not delta U1 equals delta U2, that is U1 equals U2, so it means here that delta U equals 0. Okay, so now since this is the case of free expansion, because P external equals 0, this implies that work done equals 0, and we know that delta U equals Q plus W. So work done is 0, delta U is 0. This implies that Q is also equal to 0. Therefore Q is equal to 0. Option A is the correct option. Now since T1 equals to T2 here, T1 equals to T2, and this is an ideal gas as given in the question, therefore this law will hold valid. P2 V2 equals P1 V1. Since this is not an adiabatic expansion, therefore option D is not right. And moreover, since option C is correct, option D will not be correct. So, the correct options are A, B, and C. So now let's move on to another question. The question states, hydrogen bonding plays a central role in following phenomena. A. Ice floats in water. So the structure of ice is a cage-like structure in which each water molecule is surrounded by 4 other water molecules tetrahedrally through hydrogen bonding. So this will be surrounded by this hydrogen molecule, and this will be surrounded by this hydrogen molecule, which will further be surrounded by some other hydrogen molecules, and hence this will be like this cage-like structure. It has a cage-like structure, and therefore, due to this, density of ice is less than water, and therefore it floats in water. Hence, option A is correct, because they are surrounded with each other due to hydrogen bonding, through hydrogen bonding. Now, option B, higher Lewis basicity of primary amines than tertiary amines in aqueous solutions. So, in aqueous solutions, primary amine will have this equilibrium like this. Plus OH negative. This has this equilibrium like this, and in case of tertiary amines, the equilibrium is like this. Since we know that here in this case, this is here R3, it is a lot bulkier. This group is a lot bulkier than this group, and the cation 1, and therefore this cation, the primary cation, is more stabilized through hydrogen bonding than cation 2 because of the bulkiness of this group. Therefore RNS2, therefore this group is better base than R3N in aqueous solution. This is a better base than this. RNH2 is better base in aqueous solution. Okay, so option B is the correct option. Formic acid is more acidic than acetic acid. Yeah, we know that formic acid is more acidic than acetic acid, but that is due to inductive effect and not hydrogen bonding. Therefore, option C is the incorrect option. It is due to formic acid is more acidic due to inductive effect. Okay, so option C is the incorrect option. Now, dimerization of acetic acid in benzene. Yeah, in benzene the acetic acid undergoes dimerization like this. In benzene, acetic acid undergoes dimerization like this. So here hydrogen bonding plays a central role in this process. Therefore, option D is the correct option in this case. Okay. So now moving on to another question. Question states, in a galvanic cell, the salt bridge A does not participate chemically in a cell reaction. Yes, option A is correct. A salt bridge does not participate chemically in a cell reaction. Option B stops the diffusion of ions from one electrode to another. No, it does not stop the diffusion of ions from one electrode to another, because to maintain neutrality, it may diffuse ions from one electrode to another. Therefore, option B is the incorrect option. It is not necessary for the occurrence of cell reaction. The cell reaction depends on E0 value, and hence option C is also the incorrect option. It ensures mixing of two electrolytic solutions. No, it is certainly not the correct answer. It ensures that two electrolytic solutions does not get mixed. Okay, so now let's move on to another question. Upon heating with Cu2s, the reagents that give copper metal are. Okay, so now let's write the chemical equations here in this in each of the processes. So here Cu, option A, Cu FeS2 plus O2. When it is heated, it gives Cu2s plus 2Fes plus SO2. Therefore, option A is the incorrect option. Now, CuO, when it is heated, it gives 2Cu2O. Okay? And when 2Cu2O is further heated with Cu2s, it gives 6Cu plus SO2. Therefore, option B is correct option. Option C is also correct option from this step. Now, option D, when CuSO4 is heated, it gives CuO plus SO2 plus half O2. Now, further CuO can be heated to give Cu2O, just like the option B, and further it will be heated if Cu2s, it gives 6Cu. So, option D is also the correct option. Therefore, correct options are B, C, and D. Okay, so now let's see the other question. The question states the correct statement for orthoboric acid is or are it behaves as a weak acid in water due to self-ionization. Acidity of its aqueous solution increases upon addition of ethylene glycol. It has a three-dimensional structure due to hydrogen bonding. It is a weak electrolyte in water. Whereas 3BO3 is a weak monobasic release acid. Here we draw H3BO3. What does it happen to it in water? So it undergoes association instead of dissociation. So it is a weak acid in water. It behaves as a weak monobasic release acid in water, but not due to self-ionization. It is due to dissociation. Okay. It is due to association, not dissociation. Okay, so now option B. Here, acidity of aqueous solution increases upon addition of ethylene glycol. So here in aqueous solution, it stays in this form. So the structure can be like this. Okay, the structure can be like this. So the structure is like this. Now, upon addition of ethylene glycol, it will undergo the reaction like this. Here, this will be fetched by ethylene glycol, this will be fetched by it, and again this species will also get fetched by it. Okay, so now the reaction product is somewhat like this. Now, this equilibrium is shifted in forward direction by addition of syndiols like ethylene glycol, which forms a stable complex. Now, this equilibrium, it is shifted in forward direction, in this direction, by addition of syn glycol, because here BOH whole 4, here this is whole 4. So here BOH whole 4 gets consumed by ethylene glycol, and hence this equilibrium is shifted in forward direction. Therefore, option B is the right option. Its acidity in aqueous solution increases. Now, option C is incorrect because it has a planar sheet-like structure due to hydrogen bonding. It has a planar sheet-like structure. Okay, so option C is the incorrect option. Option D, it is a weak electrolyte in water. H3BO3 is certainly a weak electrolyte in water. So option D is the correct option. So the correct options are option B and option D. Okay, so now let's see other question. The question states, for the reaction I negative plus ClO3 negative plus H2SO4 gives Cl negative plus HSO4 negative plus I2. The correct statements in the balance equation are stoichiometric coefficient of HSO4 negative is 6, iodide is oxidized, sulfur is reduced, H2O is one of the products. So if we write the balanced equation, the correct balanced equation, the balanced equation will look like this. 6 I negative plus ClO3 negative plus 6 H2SO4 gives 3I2 plus Cl negative plus 6 HSO4 negative plus 3H2O. So option A, stoichiometric coefficient of HSO4 negative is 6. This option is correct. Iodide is oxidized. This option is certainly correct because here the oxidation state of iodine is its iodide is -1, and here its oxidation state gets changed to 0. So therefore iodide is oxidized. Sulfur is reduced. No, this option is not correct because here the oxidation state of sulfur is 6 and here as well it is 6. So therefore sulfur is not reduced here in this case. Now H2O is one of the products. Option B is right. Option B is the correct answer. So there, option D is the correct answer. So therefore the correct options are A, B and D. Okay, so now let's move on to another question. The pair of reagents that yield paramagnetic species are. Now Na in excess of NH3, yes, it yields a paramagnetic species. Na in excess of NH3 is deep blue color. It shows a very deep blue color because of solvated electron. It has a solvated electron, like Na plus NH3 gives E negative and H4 positive. It has a solvated electron, and therefore it shows a deep blue color, and hence this is a paramagnetic species. It yields a paramagnetic species. Therefore option A is the correct option. In option B, K in excess of O2. K in excess of O2 undergoes reaction like this, KO2, where KO2 is paramagnetic. Okay, so option B is also the right answer. In option C, Cu and dilute HNO3. Cu in dilute HNO3 undergoes reaction like this. 3Cu plus 8HNO3 gives 3CuNO3 whole twice is this NO3 whole twice plus 2NO plus 4H2O. Okay, now here NO is paramagnetic species. Paramagnetic species. Therefore option C is the right answer. Now in case of option D, O2 and 2-ethyl anthraquinol. Well, 2-ethyl anthraquinol, the structure of 2-ethyl anthraquinol is like this. Okay, the structure is like this. So in case of reaction with O2, that is air, it undergoes oxidation like this. This bond will look here. Okay, so if you draw all the double bonds, the bonds will look like this. The bonds will look like this. Okay, So here, this species H2O2 is released as a byproduct, and H2O2 is diamagnetic. Okay, so therefore option D is not the correct option. The correct options are option A, option B, and option C. Okay, so now let's move on to the next question or to the next section. Now consider all isomeric ketones, including stereoisomers of molecular weight equals 100. All these isomers are independently reacted with NaBH4. Stereoisomers are also reacted separately. The total number of ketones that give a racemic product is R. Okay, so now first let's draw all possible isomeric ketones. Okay, so there are 6 possible isomeric ketones with molecular weight 100. So the first is CH3, CH2, CH, CH3, C, CH3. Second is CH3, CH2, 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 C, CH3. Third is CH3, CH, CH3, CH2, CH, double bond O, CH3. Fourth is CH3, C, CH3, CH3, C, double bond CH3. Now fifth is CH3, CH2, C, double bond O, CH2, CH2, CH3. And the sixth one is CH3, CH2, C, double bond O, CH, CH3, CH3. Okay. So now here in all the cases, the reactant will give a racemic mixture on reduction with NaBH4 in all these except for this one. Okay, so in all the cases the reaction will give the racemic mixture. In all cases reactant will give racemic mixture except one. Then the reason is that it has a chiral carbon here. Okay, since it has a chiral carbon, therefore on independently reacted with NaBH4, it will not give the racemic product. Okay, so the correct answer is the correct answer is the answer 5. Okay, the correct answer is 5 here in this case. Okay, so now let's move on to another question. Question says a list of species having the formula XZ4 is given below. XeF4, SF4, SiF4, BF4 negative, BrF4 negative, and so on. Define shape on the basis of location of X and Z atoms. The total number of species having a square planar shape is, well, the square planar shape XeF4, it has a square planar shape, no doubt. SF4, it has a seesaw shape. SiF4, it has tetrahedral shape. Okay, now BF4 negative, it has tetrahedral shape. BrF4 negative, it has square planar shape. Okay, now Cu NH3 whole 4 2 positive, it has square planar shape. Square planar here because NH3 is a high polarizing ligand. Okay, so FeCl4 2 negative, it has tetrahedral shape. Now COCl4 2 negative, it also has tetrahedral shape, and PtCl4 2 negative, it has a square planar shape. Okay, so the total number of species are 1, 2, 3 and 4. So the correct answer in this case is 4. Okay, so now let's move on to another question. The question states, among PBS, CUS, HGS, MNS, Ag2S and so on, the total number of black colored sulfides is. Okay, so now here PBS is black colored sulfide. PBS is black colored sulfide. CUS is black colored sulfide. HGS is black colored sulfide. Ag2S is black colored sulfide. And IS is also black colored sulfide. And COS is also black colored sulfide. So the correct answer in this case is 6. Now here I would like to quote one thing. The note is that in case of Bi2S3, okay, it is dark brown in crystalline form. Okay, dark brown in its crystalline form. Okay, but black when precipitated. Okay, but black in color when precipitated. Okay, so here in this case the correct answer is 6, because it is not given whether the compounds is just precipitated or not. Therefore we are going to assume that they are well stable crystalline formed compounds. Okay, so the correct answer in this case is 6. So now let's move on to another question. The question says, a total number of stable conformers with non-zero dipole moment for following compound is or are. Well, here. So to go for it, we have to draw all the conformers of this following compound. You can draw conformers like BS3, BS3. So drawing all the conformers, we'll get the conformers like this. L, N, R. Let's first draw the front part of that N, R. L, N, R. L, N, R. L, N, R. Okay, so now let's draw the back part of the given molecule. Br, Cl, Me. Okay, now Cl, Br, Me. Cl, Me, Br, Me, Cl, Br. These all conformers are rotated 60 degree with respect to the previous ones. Okay, you can easily you can easily observe from here that this conformer is rotated 60 degree in anti-clockwise direction. Okay, so here. So now the fifth one will look something like this: MECl Br, and here it will look like Br MECl. Okay, so here this is unstable. This is unstable. This is unstable. So the only molecules, only conformers which are stable are, this is stable and it has mu not equal to 0, that is dipole moment not equal to 0. This is unstable. This is stable with mu not equal to 0. This is unstable and this is stable with mu is not equal to 0. Well, these are the stable molecules in its staggered form, and the unstable molecules are in their reduced form. So the correct answer in this case is the answer 3. Okay, so now let's see another question. Question says, consider the following list of reagents: acidified K2Cr2O7, alkaline KMnO4, CuSO4, H2O2, Cl2O3, FeCl3, HNO3, and Na2S2O3. The total number of reagents that can oxidize aqueous iodide to iodine is. Well, here the answer is here K2Cr2O7. Oh, yes, it does. Alkaline KMnO4, no, it doesn't. CuSO4, yes, it does. H2O2, it does. Cl2, it does. O3, it does. FeCl3, yes, it does. And HNO3, yes, it does. So the correct answer is 7. Well, writing the respective chemical reactions, we can write the chemical reactions as K2Cr2O7 plus 7 H2SO4 plus 6 Ki gives 4 K2SO4 plus Cr2SO4 whole thrice plus 3I2 plus 7H2O. With CuSO4, the reaction will look something like this: 3CuSO4 plus 4Ki gives Cu2I2 plus I2 plus 2K2SO4. Well, this is a very important reaction. You may study it in your higher studies. Well, the third with H2O2 is H2O2 plus 2Ki gives I2 plus KOH or 2KOH. The other reaction with Cl2 is Cl2 plus 2Ki gives 2KCl plus I2. Okay, and with O3, with ozone, the reaction is O3 plus 2Ki plus H2O gives 2KOH plus I2 plus O2. The reaction with FeCl3 is FeCl3 plus 2Ki or 2FeCl3 plus 2Ki gives 2FeCl2 plus I2 plus 2KCl, and the reaction with HNO3 is 8HNO3 plus 6Ki gives 6KNO3 plus 2NO plus 2NO. This is 2NO, and plus along with the products formed are water plus 4H2O and iodine plus 3I2. Okay, so the correct answer for this question is 7. So now let's move on to another question. The question says, a given molecule is there, and the question says the total number of distinct naturally occurring amino acids obtained by complete acidic hydrolysis of the peptide shown below is, well, this peptide can be broken up into different fragments, like into different constituent fragments, like this. First fragment is this. Another one can be this. The two fragments of this are there. Okay. So another one can be this one. Okay. And the third one can be this. This one. The same here, going from here to here. And the fourth one will be, the fourth fragment will be like this. Okay. So here these are the four fragments. So if we draw it, if we draw their structures, then the structures will look something like this. The structure will look something like this. H2N, CH2, COOH first. Second is HOC double bond O, NH2, CH2. The third fragment is HOC double bond O, NH2, and the fourth fragment is HOC double bond O, NH, C double bond O, OH, CH2. These are the four fragments, and out of them only this fragment is naturally occurring. This is glycine. This fragment occurs naturally. Okay, so there are on complete acidic hydrolysis of this peptide, glycine is obtained, which occurs naturally. Therefore, the correct answer for this question is 1. The correct answer is 1. Okay. So now let's move on to another question. Question says, in an atom, the total number of electrons having quantum number n equals to 4, absolute value of m is 1, and ms equals minus 1 by 2. Well, here for n equals to 4, L is 0, 1, 2, 3. Okay, and ml, that is ml is plus 1 or minus 1. Since absolute value of ml is 1, therefore ml can be plus 1 or minus 1. Okay, so there are three possible, for L equals to 0, there is no ml equals to plus 1 or minus 1. Okay, so for L equals to 1, 2, 3, there are ml equals to plus 1 and ml equals to minus 1. So for L equals to 1, ml equals plus 1 and minus 1. For L equals to 2, ml equals plus 1 and minus 1. For L equals to 3, ml equals plus 1 and minus 1. Well, there are other values of ml as well in all of three cases, but here we are asked only for ml equals plus 1 and minus 1. Now, there are 2 electrons in each of these orbitals. Okay, each of them having the absolute value of spin as 1 by 2, but their signs differ. Therefore, only one electron in each of the orbitals is present whose ms value is minus 1 by 2. So, since there are six orbitals, okay, therefore 6 electrons are there. 6 electrons with ml equals minus 1 by 2. So, the correct answer for this question is 6. Okay, so the correct answer is 6. Now, let's move on to another question. This question is solved. Now, let's move on to another question. Question states, if the value of Avogadro number is 6.023 into 10 raised to the power 23, per mole, if the value of Avogadro is 6.023 into 10 raised to the power 23 per mole, and the value of Boltzmann constant is 1.380 into 10 raised to the power minus 23 joule per Kelvin, then the number of significant digits in the calculated value of universal gas constant is, well, here K is 1.380 into 10 raised to the power minus 23 joule per Kelvin. Here N is 6.023 into 10 raised to the power 23 per mole. Well, we know that universal gas constant R is K into N. Now, there is a concept of significant digits, that the number of significant digits in the product of two or more numbers should be equal to the number of significant digits which is present in a number which has the least number of significant digits. Well, in this case, since both of the numbers contains 4 significant digits, therefore the correct answer in this case is 4. This question does not need you to multiply both of these numbers. You can, by observation only, and if you know the concepts, you can get the answer as 4. This is perhaps the easiest question of this particular question paper. Well, now let's move on to another question. The question says a compound S2X with molar weight of 80 gram is dissolved in a solvent having density of 0.4 gram per milliliter. Assuming no change in volume upon dissolution, the molarity of a 3.2 molar solution is, here we are assuming that no change in volume upon dissolution. Therefore, this implies that delta V equals 0, which implies V of solution equals V of solvent. Volume of solution equals volume of solvent. Now, since 1 liter solution contains 3.2 moles of solute, because the molarity is 3.2 here. Molarity is given to be 3.2. Therefore, 1 liter solution is almost equal to 1 liter of solvent. Okay, because and now since density is given to be 0.4 gram per milliliter, therefore this is going to be 0.4 kilogram. Okay, here it is given that delta V equals to 0. Therefore, volume of solution should be equal to the volume of solvent, and hence 1 liter of solution is almost equal to 1 liter of solvent is almost equal to 0.4 kilogram of solvent, because the density is given up to be the density of solvent is 0.4 gram per milliliter. So, therefore, molality should be equal to moles upon moles of solute upon mass of solvent in kilogram. Therefore, this is 3.2 upon 0.4. The correct answer is 8. So here the correct answer in this particular question is 8. Okay, so now let's move on to the last question of the question paper. Last question is, Mx2 dissociates into M2 plus and X negative ions in an aqueous solution with a degree of dissociation alpha of 0.5. The ratio of the observed depression of freezing point of the aqueous solution to the value of depression of freezing point in the absence of ionic dissociation is, well, if it undergoes dissociation, then the dissociation should occur like this: M2 plus 2X negative. Okay, now here the degree of dissociation is alpha. So at equilibrium the concentrations will be like this, alpha to alpha. So now from here we can get that I I equals 1 minus alpha plus alpha plus 2 alpha upon 1. Okay, so this is 1 plus 2 alpha. Now since alpha is given out to be 0.5, therefore I is 1 plus 2 into 0.5 equals 1 plus 1. The correct answer is 2. Therefore the correct answer in this question is 2. Okay, so that's all for the paper 1 of chemistry section of JEE Advanced 2014. Thank you.